Assalamu alaikum, my dear students. I hope all of you are fine and having good health. Today we will discuss about the first one physical state of matter, that is the gaseous state. So it is the state of matter, gaseous state. So we will discuss here its typical properties in detail. For example, we will discuss about its volume and about its shape. We will discuss about its unique property, that is diffusion. And third one property we will discuss about the effusion. We will discuss about its mobility. We will discuss about their compressibility, and etc. So here we will discuss about different typical properties of the gases in detail. So let's have a look on the first typical property of the gases. As the gas molecules are far away from each other, it's mean there is a long distance between the gas molecules. For example, here we have the gas, you can say that hydrogen gas, then its molecules are far away from each other and they are free to move. It's mean there is no force that is gonna to be bound these molecules, so they are free to move. They can move here and there and they can collide with one another and with the walls of the container. For example, these molecules are in a container, so they are free to move. They can collide with one another and also with the walls of the container. So there is no force of attraction and no force of repulsion between the molecules of the any gas. Next, we have the shape and volume of the gas molecules. When we're going to talk about the shape and volume of the gas molecules, as there is no force of attraction and there is no force of repulsion between the gas molecules. So all these gas molecules are free to move. So their shape and volume is basically indefinite. Indefinite mean their shape and volume is not definite. They can acquire the shape and volume of anything where the gas has been kept. So, for example, we have a closed container, a big and a small container, and we have a gas molecule in it. So, these gas molecules are free to move. They collide with the walls of the container and with one another. So, they have indefinite shape and indefinite volume. Next, we have the second one property, that is diffusion. Now, this is the new term to you guys, that what does mean by the diffusion? Basically, diffusion, it is the movement of the molecules. It is the movement of gas molecules from a region of high concentration to the region of low concentration. So, when the gas molecules move from high concentration to low concentration, there this movement is known as diffusion. For example, in this picture we have the gas A and we have the molecules of gas B. In the green, we have the gas molecules B. In the lower portion, there are more molecules of gas B, and in the upper portion, we have the more molecules of gas A. So the molecules of the gas A will start to move from top to bottom, and the molecules of the gas B will started to move from bottom to the top. So they started to intermix. Now, why they started to intermix? Because the gases have the property of diffusion. They can diffuse easily. They can move from a region of high concentration to region of low concentration, and they will make a homogeneous mixture. Homogeneous mixture. Now, what does mean by this? Homo means same, and geneous mean type. It's mean all the mixture will be of same type. There is no concentration gradient. Like if 10 molecules will move down, then the 10 molecules of the gas we will be move upwards. So the whole solution will be a homogeneous mixture of the gases, and they will collide with one another, and the molecules of the gas will have random motion. The simple example of this, if we have a spray at one corner of the room, with the passage of time, all the smell will be spread out in the whole room. Why? Because that spray is a gas and the gases have the property to get diffused. So, in the one corner of the room, as there are more molecules of the gases, so they started to spread out in the whole room. So, this is a simple example of the diffusion. Next, we have the third one property, that is diffusion. Basically, diffusion, it is the property of the gases in which basically this is the escape of gas molecules, escape of the gas molecules through the hole, through hole, and they escaped one by one without collision, and their this escape is known as effusion. For example, in this picture we have a barrier in the center, and the one side there is a gas molecules, and on the other side it is vacuum, and we created a hole in the center of this barrier. Now this gas molecule will move to the other side. So this is a simple example of the effusion, that how the gas molecules move. Now one by one the gas molecules will move from the gas side to the vacuum side. So this is a simple example of effusion. Another simple example is if we have a balloon and we created a hole in it, now the gas molecules we started to escape one by one. So this is a daily life example that we notice all around us. The escape of gas molecules from the hole of a balloon is the effusion of the gas molecules. Next we have compressibility and the pressure. So what does mean by the compressibility? As we have already learned that the gas molecules are far away from each other, and there are large empty spaces between them, spaces between the gas molecules. And when we apply the pressure on the gas molecules, these gas molecules will come close to each other, and in turn the gases will be compressed. Likewise, in this picture, for example, here we have the pressure on this gas. For example, we have 760 torr, and at this gas we have the pressure 1460 torr. Torr, it is the unit of the pressure. When we apply the pressure, now there are large empty spaces between the gas molecules. By applying the pressure, these molecules will come close to each other. In turn, their volume will be decreased and the gases will be compressed because of the large empty spaces. Next, we have the pressure. The gases can apply the pressure, and the unit for the pressure we have, or the formula we have, force per unit area. How much force is going to be applied on the unit area? This is known as the pressure, and we have the unit for the pressure, torr, we have millimeter of mercury, we have atm, and we have the pascal. This atm is the atmospheric pressure, and last one we have pascal. So these are the units for the pressure. Next we have mobility and the density. Mobility. Gases are highly mobile. Now, what does mean by mobile? They can move in the long pipes from one part of the country to the other, or the one city to the other city, because they are highly mobile. They can move through the long pipes. And why they are mobile? Because they are free to move. There is no force of attraction between the gas molecules as they are free to move. So that's why the gases are highly mobile. The density. When we're going to talk about the density, basically density by formula we have, it is mass per unit volume. It is known as the density, and its mathematical form is this: d is equal to m by v, that is mass per unit volume. So all the gases occupy all the space that they have. So in turn, the gases have low density as compared to the liquids. So you have to learn that the density of the gases is low as compared to the liquids. So these are the properties of the gases in detail. I hope you guys understand, and if you have any queries, you may ask me about in the comment section and I will get back to you guys. And the next topic that we will discuss, it is the law that is related to the gases. It is Boyle's law. For that time, have a good day and Allah Hafiz.